My name is Urvashi Mohnani, and I'm a principal software engineer on the OpenShift MCO team at Red Hat. And I have been one of the developers in the container tool space for the last few years. So today I'm here to talk to you about how we can make multi-arch image builds seamless by just farming them out. So let's get started. Okay, so before we begin, what is multi-arch, right? There are different CPU architectures out there, x86, ARM64, PPC, et cetera. And when we develop applications, if you develop for one architecture, it will most probably not work on another architecture. And the same thing applies for container images. When you are building your container images, you have to be mindful of which architecture you're building for. They are not compatible cross-architecture, basically. So when we are developing container images, it kind of gets a bit tedious to build different images with different architectures. So how do we make this a bit simpler? And one thing that the various container tools like Podman, Builder, and I believe Docker as well has done is there's something called a manifest list, which basically points to a group of images of different architecture that you can refer to by the same name. But when you use one of these container tools to then pull down this image or run this container image, it's able to detect the architecture that your machine is on and pull down that image for your architecture. So that's kind of where manifest lists come in place over here. You have one container file, you just run a build, it creates a container image, and it creates it for the different architectures and puts them together. So it's like a JSON file that has indexes to these various architectures, images of the different architectures. All right, so why multi-arch, right? Multi-arch has existed forever. It's not a new problem. But I feel like it really kind of blew up when Mac switched over to using ARM hardware. And now a lot of developers are now working on a different architecture than what we probably have in production in data centers. So it became important to be able, for developers to be able to develop on their system and able to run the same thing in production in the data centers. So we had to be mindful of that and make it easy for them to build these multi-arch images. Obviously, using different architectures comes at what kind of performance you're looking for, any cost optimizations. Running in cloud is different from running on edge devices. Every kind of hardware has different requirements. So how can we make it easy to just be able to build that container image once, but build it for the different architectures? So there are solutions that already exist. One of them is to have multiple build configurations for the different architectures, where basically you have different machines of those architectures. You log into that, build your container image there, push those container images separately to the registry, and then go ahead and build that manifest list later on. So this is a pretty manual, tedious process. It can get confusing. You have to ensure that you're keeping everything in sync over the different architectures. If anything changes, you have to update it on all those multiple machines and so forth. The other way we could do it is using emulation. So container tools, Podman, Builder, Docker, and all can use QEMU user static under the hood to emulate the different architecture and build the image for you. But as we all know, emulation is very resource intensive and can be very, very slow, and in some use cases almost 5 times slower than what a normal build time would be. And in today's world, where we're kind of in a very AI area where we're building big images, we do not want to take a hit on that and be taking a long time to build those container images. So we kind of were thinking, is there a way that we can optimize for cost and performance, but also be able to do these multi-arch image builds from one machine where a developer doesn't need to have physical access to these various machines? And that's kind of where Podman Farm was born. So quick intro, if you don't know what Podman is the container engine. It's an open source project. It was actually donated to the CNCF last year. And it's basically your all-in-one tool for developers for creating container images and playing around with containers. So we thought that, is there a way to make that manual process of building the images on different machines separately, pushing them to the registry, creating the manifest list? Is there a way to automate that with just one command where a developer can easily do that? And that's what we thought of Podman Farm. So Podman has a Unix socket that you can connect to over SSH. So we thought, why not leverage that in a way that we have remote machines of different architectures that are running that Podman socket. I have my client machine. It can be my local laptop. I can set up the connection to those remote machines just with the Podman farm build command, send all the build data needed to those machines. The builds happen there, and then the images are pushed to the registry. I get the digest back, create the manifest list locally, and then also push that manifest list to the registry. So basically everything I spoke about previously, but all just automated with one command. And that is Podman farm here. So as you can look at the architecture diagram there, I have 3 farms listed. A farm is nothing more than just a bunch of nodes. It can be as many as little as you want of different architectures. You can have nodes of the same architecture in a farm, but Podman farm build is not as smart yet. It will just build on the first architecture, the first machine it finds of that architecture. It doesn't optimize for performance that way, but definitely something that we will work on adding in the future. So as I said, you're not restricted to 3 farms. You can have as many or as little farms as you want. Same thing, the number of nodes inside a farm. On the local machine, we have our Docker file, container file with the build steps that we want. We just do Podman farm build, similar command to how you do a Podman build or a Docker build, same flags, and then all the data is sent over to the nodes. The images are built there. The image is directly pushed to the registry, so we do not pull it back to the local machine. We don't want to be transferring files back and forth and taking a hit on performance again. So we directly push it to the registry, and then when we get the digest back, we create the manifest list. So after you build it, when you want to do a Podman run or Docker run, then the container tool will detect the architecture and pull down that image for you. So this is what Podman farm is. So it's always fun when you get to see a demo of this working. So I have a demo for you here. I've recorded it before because demo gods sometimes are not in our favor. So my demo here starts with me in the AWS console. I have 2 machines here, a RHEL AMD machine and a RHEL ARM machine, EC2 instances. And what I'm going to do here is I have SSH'd into the instances here, and I'm going to enable the Podman socket. So as you can see here, this is the ARM machine that I have. And all I have to do is install Podman, which I did beforehand, and just enable and start the socket. We can see the status that the socket is up and running. And I started as the user I've logged into because I want to run without root. I don't need root to run my builds and containers. And then similarly, in the AMD 64 machine, I'm doing the same thing there, enabling and starting the Podman socket. And that is all up and active now. So now I'm back on my local machine here. And the first thing I'm going to do is I'm going to set up those connections to the machines that I just enabled. So for that, you use the Podman system connection command. You just basically give it a path to the Unix socket. As you can see here, it's EC2 instance, the IP there, and then pointing to the Podman socket. And as you see, I added the RHEL AMD and RHEL ARM ones over there. So this basically tells Podman that these are Podman sockets running on remote machines that you can access. And the next thing is the Podman farm command. So with Podman farm ls, you can see how many farms you have created. I'm going to create a new farm here. I'm going to call it defconf because I recorded this for a previous demo. But I'm just going to create that farm and add RHEL AMD and RHEL ARM inside that. So we see here that we have 2 nodes, 2 machines in that farm there. Currently in my system, I have no images built because it's empty. And here, I'm just going to build the Llama CPP Python model server image, which is a pretty big image. And we're going to time how long that takes when we do the Podman farm build command. And the Podman farm build command, all I have to do is specify which farm I want this build to go to, so which nodes I want it to go to. I give it a fully qualified image name. That's because we're directly going to push the image to the registry after it's built. So I need to give it the full registry repo image name. And if you're wondering how does it get the authentication to push the image to the registry, we basically, the authentication is on a local machine, and we pass that data on to the nodes as well when we send the build information there. So your auth stuff is not living on the nodes, it's on your local machine. So once we start that, we can see it gives us some logs. It tells us it's been able to connect to the different nodes. It tells us the farm is ready for build. And if you see over here, it's also able to detect the architecture of the machines in the node, the machines in the farm. So we have the ARM64 and AMD64 there, and it gives you the similar build output as you would see with any like container build, like Podman build, Docker build command. You will see it'll be showing it for both AMD and ARM. These builds are happening in parallel on the nodes, but we wait for all the builds to finish before we push the images to the registry, because certain image registries are very restrictive about how long an unnamed image or untagged image can stay on the registry. So it kind of does a lot of cleanup very quickly, and we want to avoid that case. So here we see that this image build took around 3 minutes and 8 seconds. And we will compare this to when we do it with emulation. But yes, when we build an image on the nodes, it is unnamed, untagged. When we push it, it has the tag that we gave when we did the farm build, but it's still, I'll show you what it looks like. It's basically just child manifests under that image. So now when I do Podman images here, I can see the manifest list has been created. And when I inspect the manifest list, you can see the index pointing to the ARM64 and AMD64 images. So those two images were built and pushed. So now let's go on to Quay, which is where I pushed my image. And when we take a look under tags, it created the latest tag by default. We can see here that under the child manifests, both the architecture images are available. So now when I go and I pull down Mohnani 8 Llama CPP farm, it will detect the architecture that my machine is and pull that image down for me, and I'll be able to run it without any issues. Okay, so now let's compare this to the process of when you're not using Podman farm and when you have to create the manifest list manually. So the first thing I have to do is you have to use the Podman manifest command to create this list. It creates an empty manifest list because we haven't put anything in there. And then to do this, we're going to use the platform flag here, which specifies which platforms I want to build for, which is AMD64 and ARM64. And I'm going to time this. So this is using emulation to build it on my local machine. It's using QEMU user static to build it. And we're just going to see how long that takes. I'm going to just fast forward a bit so we don't have to sit through that. It went way too ahead, sorry. There you go. So as you can see here, the build took around 11 minutes and 35 seconds. And that is like almost 4 times slower than how long it took for farm build to do it. And that's because farm build was building on machines of those native architectures. We're not emulating anything there. Similarly here, when I inspect the manifest list that I created, I can see that images for those two architectures, it has indexes to those two. So it works as expected, but it is slow, and you have to do all of that manifest list creation, pushing the images and everything on your own. Okay, so this was Podman farm versus not using a farm. It was showing you how the time difference in doing that with emulation versus not emulation. But I also wanted to go a bit more into detail into the farm command itself. So this is the farm help. We saw we were able to create the farm with list. We can list the farm. We can obviously remove and update farms. And the most important one, obviously, is farm build over here, which does the main thing that we want to be doing in building multi-arch images. So in this demo, I also have 3 farms. And my farm 1 has 2, the Fedora 37 and Fedora 38 ARM machine. The other 2 only have one node in it. So this is a much simpler Docker file. I'm just kind of running the arch and date. And I just did a Podman farm build helpline. I just wanted you to see all the flags and options available, which is basically what you have available in a regular Podman build. There's nothing different here. It's just to highlight that we are using existing tools and technology and just putting them together to help create this kind of seamless experience. Here, we're just going to do a quick farm build. One thing I want to point out with this is this local flag. You probably saw it when I showed the earlier demo. So by default, we set local to true. What that means is that when the build happens, it will build an image on your local machine as well as the nodes in the farm. But if you don't want to do that, you just set local to false, and it will just build on the machines in your farm. So similar thing here, just creating a new build. It detected the different architectures, as you see, ARM64, AMD64, and it's doing the build over here. Let's skip ahead. Yep, so my image one is created. Similarly, we'll inspect, and as expected, we'll see the two different architectures there. One thing I want to show here is when I now build, I'm leaving local to true. So I haven't set that to false explicitly. It's going to use default behavior, and it's going to use the default farm, which I think was farm 2. And as you see here up above, it detected setting up local builder. So it detected my machine's architecture here, which is AMD64, and it's building on my machine as well as that one node in the farm. One thing I want to also highlight here is for the machine, the build in the farm, you will see it's using cache. So because I had just run a build previously on the same node, the cache was lying around, so it didn't redo the whole build again. It's following the same ideology as we do with Podman builds locally. It will use cache if it detects a cache. And one more thing here, now you can see when I do Podman images, I have a lot more images on my machine now. And this is the unnamed, untagged image that was created for the build when I did it on my local machine. And now when I inspect image 2, same thing because it built on my local machine as well as that one ARM machine in the farm. I have the two indexes there. And I'm just going to skip ahead a bit here. One last tool I wanted to show is this cleanup flag. So what this flag does is after the build is complete, it will clean up the image that was built on the node after it's pushed to the registry successfully. So this way you don't have, after a bunch of builds and everything, you don't have a lot of images lying around for no reason on your nodes. If you know that you're not going to need to use it again, you don't want to have cache around, it will do the cleanup process for you right immediately after the build is done. So because this one only built on one machine, you only have one index on the manifest list, which is the AMD64 one. And here I've SSH'd into that node specifically. And when we do Podman images, you see that there is no unnamed, untagged image there. The image that was built has been cleaned out. So that is basically some of the technical, some fun like quirks of the Podman farm command. So just a quick recap. You have your local machine, you have the nodes in your farm. These can be virtual machines. As I showed, I had EC2 instances. They can be other physical machines that you can connect to within your network. They just have to have Podman installed and the socket enabled. You set up the connection one time on your local machine, and whenever you do Podman farm and specify which farm you want to send it out to, it will always send the builds there, do the builds, push them to the registry, and create the manifest list for you. So this whole process of building multi-arch images is just done in one step, and it's there to make the developer's experience better. Okay, so just kind of tying this back together, the importance of multi-arch, with AI becoming such a big thing now, AI engineers, data scientists are most likely always just programming and on Macs, which are almost always going to be a different architecture than what is being run in your data centers. You want to ensure there's collaboration between different architecture users. It's important to be able for developers to have this ability to build multi-arch images. On the edge, as we saw in the keynote yesterday, there's so many different kinds of devices being used at the edge, all have different hardware requirements and resource constraints. So that's where it is also important to have those multi-arch images. You want to be able to build once and deploy in different locations as many times as you want to. And finally, image-based operating systems. So this is where we are packaging operating systems, including the kernel, in the form of a container image and distributing them. So this is also essential because for different architectures, you have different kernel drivers, different toolkits, et cetera. So kind of bringing all of this importance of ease to make your multi-arch images. So here are some resources. These are links to the demos that I showed you and links to our documentation for Podman Farm. Please try out Podman Farm build if you're someone who is involved in multi-arch builds on the regular. It is an open source project. If there's something that you wish you had in that, please open issues. We're welcoming contributors as always. Try it out. Thank you all. So the question is, how does the authentication for the Podman socket protocol work? So it is a Unix-based socket, and when we enable it, Podman system connection on the client side is able to talk to it. I don't know the nitty-gritty of the technology behind it, but it is a Unix socket, and it talks to it over SSH. So if you have I think SSH key, you will have to pass. We are able to pass that to the system connection LS, the system connection command, so it's able to look at that to authenticate. And any authentication for your registry lives on your local machine, and we just pass that data along to the build nodes whenever we're building. Yes?
But Podman provides solution for caching mechanism. For instance, like you have nodes, you build images, you said you have a cache state. So that's how you use the similar thing.
Sorry.
You can speed it up.
Sorry, can you repeat I couldn't hear the question. Yeah.
The Podman farm support the cache mechanism, something like when you build it once and build second time, you have cache there.
Yeah.
Use to reduce the time, but if you're adding extra node, does it always need to restart from the beginning and have the cold start issue, or does it have some sort of shared cache you can use?
Okay.
Something like that.
So I think your question is, do the nodes in the farm have some form of shared cache?
Yeah.
No, the nodes in the farm do not have a shared cache, but when you do your initial build, the initial build will do a full proper build, and those cached layers will be there on the nodes. So whenever you do another build of the similar container file, if you only changed one thing, it will reuse the cache and then just update it for what has changed. So just kind of how a normal build works. There's nothing special about, there's no shared cache, basically, no.
Do you have any plans?
As of now, no plans, but you're welcome to open an issue, and the maintainers will take a look at it, yeah. Yes?
I have a lot of stuff to talk about this later, so I'll grab you afterwards.
Okay.
I'm really heavily involved with the building of container images for my company. And one thing that I come across that's sort of an issue for us is in the case of having like a big farm of image builders or something like that, we have thousands of developers in our company. They're constantly building stuff all the time. It costs a lot of money to constantly leave these EC2s on.
Mm-hmm.
So any thoughts on that, about how we can avoid that sort of thing? I understand you can make smaller EC2s, ARM is cheaper and whatever, but any thoughts on that?
Yeah. So the question is, any thought, like it's expensive to leave all these EC2 instances on all the time. Any thoughts on how we can optimize on that? And the answer is not really. I don't think there's a better, I'm sorry, I don't think I have a better answer to that. Yeah, agreed, yes.
You said very early in the presentation about setting up the farms. You had some commands you executed to tell your computer which machines were which farm.
Yeah.
Is that data exportable or manageable in some way so that if you've got more than one developer doing the same thing, they will have the same configuration?
So the question, is there a way to do the setup, like make it a standardized thing to set up the farms? As of now, it's only in that command. You just do podman farm create. There is no, the only way I can think of standard is like having a document that says follow these steps and to set up your farm at the beginning for all the developers. But other than within the farm command, no, we do not have anything like that right now. Yeah.
Is it a good approach to deploy a farm into any Kubernetes cluster?
That's a good question. Is there, sorry, what?
Is this a good approach to deploy it in the
Kubernetes cluster? Is this a good approach to deploy in a Kubernetes cluster? So this wasn't really made with clusters in mind. I think clusters itself have other solutions like Tecton pipelines and stuff that help with these kind of builds. This was kind of made for more developer use case and having machines around that they can send the builds to. So I don't have a good answer to that. I'm sorry. Yes.
So you had a Podman farm that you created, and you had your example, 2 different platforms or architectures. Were those both using the same image file?
Yes, they were both using the Llama CPP container file.
You had your from instructions, like a UBI9 image?
Yeah, so it's whatever was in the Llama CPP container file, yeah. It was exactly the same container file we built once with using farm nodes. So that was using the architecture natively, and once that was doing on my machine, but using emulation to emulate the ARM architecture.
Gotcha.
Yeah.
And does that pull, in that query registry, does that pull any other sort of images with Podman Farm behind the scenes?
No, no. It's on the nodes, it's basically a Podman build that's running. It's exactly the same thing. There's nothing else happening.
Gotcha.
Yeah.
I just thought of something actually. We mentioned that when it comes to multi-architecture builds, it's possible that somebody else's upstream image that you're using, maybe they did the thing where they have an image that's literally named -arm or whatever, right?
Yeah.
Or maybe you have to do something in your image that's specifically grabbing a binary that literally has -arm at the end of the name of it. Is that is the architecture available as like a variable inside the container file at build time? Because otherwise, how else are you going to know that?
So when we create a manifest list, the manifest list is able to know the architecture, and it shows that data for you.
Yes, but like inside a container file or something, like maybe you wanted to do like download the OpenTofu binary or something like that, right?
Yeah.
And there's a different binary, of course, you know, for ARM or AMD. But how do you write that run instruction in your container file and reference the architecture that thing is currently building on in Podman? If you
Yeah. So that would, okay, so that's what I'm saying, that Podman is able to detect the architecture. So when you're building the base image that you have specified, it will pull the base image of that architecture to build on. And then whenever you're doing your run, DNF install, tofu or whatever, it will be installing for that.
Yes, but what if it's something like a curl command that you literally just stick it inside the string?
That,
That's a lot of stuff.
yeah, that I don't know.
Okay.
I'm sorry,
Gotcha.
yeah.
There's a lot of questions.
Okay. I'm not an expert in multi-art builds, but I'll help us until I can. Yes.
It does, yeah, that's exactly what I was thinking.
It should have it if it's there, yeah.
Yeah, I'm thinking ahead to bait, if you've used Docker bait before, but.
Great question so far, thank you.